Hello and welcome back all the viewers. I Miss Rupali welcomes you all on my YouTube channel, that is Bhumi's Physics Tutorial. So we have started with Unit 2, that is electricity, magnetism and semiconductors. Today we are going to talk about the important concept related to the electricity, that is electric potential. Okay, so let's start with the electric potential. So first we'll see the meaning of electric potential. So the electric potential is the amount of work done required in bringing unit positive charge from infinity to that point against the electric field. इसका मतलब क्या हुआ कि एक यूनिट पॉजिटिव टेस्ट चार्ज है दैट इज़ एट अ डिस्टेंस ऑफ इन्फिनिटी, बराबर है, वो बहुत दूर है इलेक्ट्रिक फील्ड से. वी वांट टू ब्रिंग दैट पॉइंट टू द पॉइंट वेयर वी वांट इट. ओके, उस पॉइंट तक हमें उसको लेके आना है, बट हियर दैट इज़ we need to do the work which is against the direction of the electric field. So whatever amount of work done is required that to bring that unit positive test charge from infinity to the point where we want, that at that point whatever work is required, that is equivalent to the electric potential. So from this, whatever work done is required, that is equal to the electric potential. ये आपको ध्यान में रखना है. Okay, so here there is a one charge which is plus Q charge, which is placed at point O. Okay, now there is a unit positive charge which is placed at infinity. ओके, ये समझ में ले लो. नाउ ये जो पॉजिटिव चार्ज है यहाँ पे, विच इज़ द सोर्स चार्ज, ओके, इट इज़ अ पॉजिटिव चार्ज. सो द फील्ड विच इज़ प्रोड्यूस्ड, electric field which is produced, that we are considering radially. So this is the direction of the electric field which is produced by this source charge. Okay, ये actually everywhere in the circumference of the charge it is creating the electric field, but for our convenient we are considering this is the direction of the electric field because we have placed our charge at infinity. Okay, now what we want is, we want to bring this charge which is at infinity to point P. Okay, so whatever work done is required and that is against this electric field. So this work done we want to find out, and जो work done है which we want to find out at point P, that is equivalent to the electric potential. Okay, so we will see how to find out the electric potential due to a point charge in detail. Okay, electric potential due to a point charge. So again, if you look at the diagram, you will note that plus Q is the source charge, you can say. Then there is a point और द चार्ज विच इज़ एट इन्फिनिटी, जिसको हमें P पॉइंट तक लाना है. ओके, कैन यू सी द पॉइंट P? टिल दैट वी वांट टू ब्रिंग दैट चार्ज फ्रॉम इन्फिनिटी टू पॉइंट P. नाउ एट इन्फिनिटी ऑब्वियसली द पोटेंशियल, electric potential is 0. Therefore, I have wrote here that VE is equal to 0. Okay, the distance between this plus Q charge and the point P is R. Okay, now what I'll do is, first I'll bring this charge which is at infinity to point A. Okay, and that is obviously against the direction of the electric field. So जो भी work करना पड़ेगा, that is equivalent to the electric potential. But before that, we will find the Coulomb's force between the two charges. पहला जो चार्ज है वो हमारा सोर्स चार्ज है, this one, right, which is positive charge. Okay, now the other charge which is at infinity, वो हमें point A तक लाना है, and the distance between the source charge and the point A is x. Okay, now the charge which we are bringing from the infinity to point A, it has a charge of 1 coulomb, and therefore according to the Coulomb's law we know Fe, which is electric field, which is equal to K, capital Q, into the magnitude of the charge which is at point A is 1 upon the distance between the two charges, that is the distance between, we can say this is the point O and the point A, that is x, and therefore according to the Coulomb's law we know it is inversely proportional to the square of the distance. So we got this equation according to the Coulomb's law, it is Fe is equal to kq upon x square. Okay, now what I'll do is we'll bring that charge from point A slightly towards the point P. Okay, so again I need to do a small amount of work to move that charge from point A, okay, to a certain distance. So let us consider that displacement as dx. Okay, so through displacement of dx I move that charge towards the point P. So while moving that charge, work has to do on that charge, and that work done, small work done, that is equal to force into displacement. Okay, so dw is equal to vector Fe into dx vector. Now to remove this dot product between force and the displacement, we need to take cos theta. Okay, and as the angle between the electric field, this is the direction of the electric field, and the dx is 180 degree, therefore I take cos as 180 degree, and as we all know that cos 180 is equal to minus 1, and we got the value of Fe from equation 1, so just substitute the values, we'll get that small work done which is equal to minus kq upon x square into dx. Now this is the small work done, okay, but we want to bring that point to the point P. Okay, point P तक हमें उस चार्ज को लाना है, and for that we will consider the integration. Okay, so integrate this equation. Okay, integrate के लिए लिमिट होना चाहिए, तो फ्रॉम इन्फिनिटी टू पॉइंट आर क्यों लिया है हमने यहाँ पे, बिकॉज जो हमारा चार्ज है विच इज़ द सोर्स ऑफ इलेक्ट्रिक फील्ड प्लस क्यू, and the distance between the charge which is at infinity we are bringing to the point P, वो जो distance है वो R है. Okay, so for that the work done is equal to integration from infinity to point R, which is equal to minus kq upon x square into dx. Got this? Next we will take out the common, that is minus kq integration of infinity to r x raised to minus 2. We have just taken this x which is present in the denominator to the numerator. Integrate this x raised to the power minus 2. On integrating that, what we are getting is w is equal to minus kq x raised to minus 2 plus 1 upon minus 2 plus 1. Okay, and then substitute the values, limits जो है वो हम substitute करेंगे. On substituting, what we are getting is work done is equal to kq 1 upon r minus 1 upon infinity. 1 upon infinity is 0. Okay, so what we are getting finally is kq upon r, and the work done which we required to move that charge from infinity to point P is nothing but the electric potential at point P. Therefore, we have equate W is equal to V, that is work done is equal to electric potential. So this is the electric potential which is required to move the point charge from the infinity to point P. Okay, and from this equation we can say that this electric potential depends on the magnitude of the charge and the distance. So got how we have found the electric potential? It is very simple. Okay, अगर आपको एक बार देखना है तो you can just have a look over it. Okay, so let's now talk about the what is meant by 1 volt. So 1 volt is equal to 1 joule upon 1 coulomb. Okay, it is the unit for electric potential, 1 joule upon 1 coulomb. The potential at point is said to be 1 volt if 1 joule of work is done in bringing a unit positive charge from infinity to that point. So it is the definition of 1 volt. It can be also asked. So ये आपको भी ध्यान में होना चाहिए कि unit potential मतलब कितना होता है. So potential at any point is said to be 1 volt. कब आप कहोगे उसको 1 volt है? Okay, potential जब 1 joule of work done किया जाएगा in moving that unit positive charge from infinity to that point. Okay, so unit आपको ध्यान में रखना है and the definition of 1 volt. Next concept related to this is the potential difference. Okay, so ये potential difference, this concept also you have learned in the primary levels. Okay, that is, let's understood this concept with the help of an example. Let us consider two water containers A and B which are connected by a tube. दो containers है, okay, and they are connected to each other by a tube. The water level will flow through a tube only when there is a water level difference between A and B. बराबर है. कंसिडर करो कि ये जो सरफेस है दोनों का वो सेम है. So water will obviously flow whenever there is a level जो होगा water का वो अलग अलग होगा. अगर सेम लेवल होगा वाटर का, सो ऑब्वियसली द वाटर विल नॉट फ्लो फ्रॉम वन कंटेनर टू द अदर कंटेनर. ये तो हमें पता है. तो वाटर लेवल डिफरेंस होना चाहिए तभी तो वाटर फ्लो होगा. सो एज वाटर फ्लो और द वाटर लेवल is the factor deciding the flow of water, similarly charge level, that is the potential, is the factor which decides the flow of charges. बराबर है. अगर किसी भी चीज़ में इक्विलिब्रियम है तो कौन सी भी चीज़ यहाँ से वहाँ ट्रांसफ़र नहीं हो सकती है. बराबर. जैसे पानी, अगर दोनों लेवल इक्वल है इन बोथ द कंटेनर्स तो वाटर जैसे फ्लो नहीं होगा. सिमिलरली वी कैन अप्लाई दिस कंसेप्ट टू द चार्जेस ऑल्सो. अगर चार्जेस भी दोनों तरह सेम है, दो इट इज़ पॉजिटिव और नेगेटिव, बट अगर लेवल सेम हो, नंबर ऑफ चार्जेस सेम हो दोनों साइड में, सो चार्ज फ्लो नहीं होंगे. देयर हैज़ टू बी अ डिफरेंस, देन एंड देन ओनली द चार्ज विल फ्लो. ओके, and that is nothing but the potential difference. Now to understand this, consider a point charge plus q as shown here. In A and B are the 2 points in the electric field, okay, of charge plus q. Reference between the 2 points A and B is the work done in bringing unit positive charge from point B to point A. तो यहाँ पे डायग्राम से ही आपको समझ में आ रहा है, लाइक इन द प्रीवियस डायग्राम ऑल्सो वी हैव डिस्कस्ड, वैसे ही ये डायग्राम है कि एक यहाँ पे इलेक्ट्रिक फील्ड प्रोड्यूस कर रहा है, वो चार्ज है विच इज़ प्लस क्यू. ओके, एक पॉइंट है, चार्ज है इन्फिनिटी पे. ओके, सो वो इन्फिनिटी से ए बी तक लाया एंड देन अगेन फ्रॉम बी टू ए उसको मूव करना है, एंड दैट इज़ अगेंस्ट द डायरेक्शन ऑफ द इलेक्ट्रिक फील्ड. अगर वो चार्ज पॉजिटिव है तो यू नीड टू डू अ मोर वर्क ऑन दैट, बराबर है ना, बिकॉज पॉजिटिव क्या होता है, रिपल्शन होता है. तो अगर ये भी पॉजिटिव है और ये तो पॉजिटिव ही है, सो देयर इज़ अ रिपल्शन, सो यू नीड टू डू अ वर्क अगेंस्ट दिस फील्ड. समझ में आ गया? नाउ लेट्स सी द potential at point A. So we are considering these 2 points A and B. So what is the potential at A? जो हमने पहले वाला फॉर्मूला देखा, which is KQ upon R. So this point A is at a distance of R1 from Q. Therefore potential at point A, VA, that is equal to 1 upon 4 pi epsilon naught epsilon or Q upon R1. Okay, and then what is the potential at point B is VB is equal to 1 upon 4 pi epsilon naught ER Q upon R2, because this B, the distance between the B and this plus Q charge is R2. okay, and potential difference निकालना है हमें between the point A and B. एंड ऑलवेज रिमेंबर कि ज़्यादा से कम हम सबट्रैक्ट करते हैं, तो वी बी माइनस वी ए, एंड वी विल गेट द फॉर्मूला ऑन सब्स्टिट्यूटिंग द वैल्यूज ऑफ वी बी एंड वी ए एज पोटेंशियल डिफरेंस विच इज़ इक्वल टू 1 upon 4 pi epsilon naught epsilon r into q upon r2 minus q upon r1. So easy है, simple है. This is the way we can find out the potential difference between the charges also. So today we have talked about the electric potential, okay, and bringing a unit positive charge from an infinity to the point we want, and we have talked about the potential difference. So if you like the videos, please share, like, and do press the subscribe button for the latest updates. Thank you.